Numbers that multiply to negative 30 and add to positive 7. What you come up with? Negative 3 and 10. Good. So I'm going to put an x minus 3 and an x plus 10. Now you look at what can cancel. The only thing I can cancel is x minus 3. And that's going to leave me with a final answer of 8 over x plus 10. Make sure your name is on your bell work and pass it to the front. In your notes, we're going to go to page 6. Yes. All right, go to page 6. We're going to start factoring. Do we have to do a keep change flip for question C? Nope. So let's start factoring. And again, when you factor, you're looking for a greatest common factor, or just, if it's an x squared, then you'll probably need to make an x. Or it could be a pattern. So when I'm looking here, p squared minus 36 is actually a pattern. And it's called the difference of two squares. So what will that factor down to? P goes in the front. What number will go in the back? Well, multiplies to be 36. And on your multiplication chart, I think those numbers are going down at a diagonal. Yeah. 6. One is plus, one is minus. Hold on. All right. My denominator doesn't have a GCF, and I can't factor it, so I'm just going to write it as it is, no changes. They've already factored out the GCF, no changes. And lastly, we have a p squared, but we don't have to make boxes. You need two numbers. They multiply to be negative 48 and add to a positive 2. So take a couple minutes, see if you can find your two numbers. Anybody know the numbers? Isaiah? 6 and 8. Good. Which one would be negative, the 6 or the 8? The 6. Yep, the smaller number. So now that everything is factored, we can connect it. And you're just looking at what you can cross out. It has to be upstairs and downstairs for you to take it away. So what's something upstairs and downstairs that we can cross out? The p plus 6 can go away. And the p minus 6 can go away. Can anything else go away? All right, so my final answer would be 6p times p plus 7 over p plus 8. And you don't have to distribute that. You can leave it just like that. Any questions? So we just got a lot of factoring to do. We got to factor it so we can know what can cancel. So let's look at question D. Do we need to do a keep, change, flip for question D? Yes, let's do that. Keep, change, flip. So I'm going to keep my first fraction. I'm changing division to multiplication. And I'm flipping the second fraction. All right, so let's go ahead and get started. So sometimes your factoring is just taken out of GCF. So the only thing I can do with 8m minus 64, I feel like we had this on the last one. Maybe it was on the bill work. All right, 8m minus 64 is take out of 8. Which means you're dividing 8m by 8 and 64 by 8. So when you divide the 8m by 8, you're just left with m. What's 64 divided by 8? 8. And that's all over. Can I do anything with this m plus 1? Yeah. Nope. So we're going to leave it the same. All right, let's go to our second fraction. So we have a square, and let's see if we can factor it down. In order to factor it, we need to find two numbers to multiply to 5 and add to 6. And there's only one thing we can multiply to get 5. What can I multiply to get 5? Yep, both positive. So put a plus 1 and a plus 5. And can I do anything with this m minus 5? Does that have a GCF? No. All right, so now that we have it all factored down, I'm going to connect it and cancel out what we can cancel out. So the one thing I know I can cancel out is m plus 1. And I almost made a mistake first period. Can I cancel these out? No. One is a plus and the other one is a minus. So that was the only thing we could cancel out, was just the m plus 1. So my final answer is I have an 8, a m minus 8, a m plus 5, and an m minus 5. And that would be your final answer. So again, don't make the mistake that I almost did. You cannot cancel it unless it's an exact match. Sometimes we can factor it and nothing cancels. Sometimes we factor it and everything cancels. All right, let's look at question E. Do I need to do a keep, change, flip? All right, let's start factoring. There is nothing I can do with 3a. So that's going to stay the same. Okay, this actually has a GCF of a number and a variable. Let's start with the number. What's the biggest number that we can divide into 4 and 20? 4. And now we need to figure out how many apples I can take out. The first one has 3. The second one has 2. So I can't take out more than 2. So I'm taking out a 4a squared. So that's the GCF that's going to be on the outside. And now let's see what's left. So 4 divided by 4 is 1. Remember your exponent laws. I have 3 upstairs and 2 downstairs. When you subtract, you're left with 1, and that 1 is going to stay upstairs. Plus 20 divided by 4 is 5, and your a squared is canceled. Let's move to our second fraction. It has a square. It's not the difference of squares, so let's see if we can factor it down. In order to factor it, we have to find 2 numbers that multiply to 25, but add to 10. Anybody have numbers? Give y'all a second to think about it. Isaiah again. 5 and 5. Both positive. And then my denominator, they already factor for us. All right, now that everything is factored, I connect it and cancel what you can. So I could take away the 3a. What else can I take away? Now, there's 2 upstairs and 1 downstairs, but you can only take away 1. 1 from the top and 1 from the bottom. We don't cross out the both of them. It's 1 for 1. So now, let's write what we have left for our answer. Our answer is we have a plus 5 upstairs and 4a squared times a plus 4 downstairs. For question F, do we need to do keep, change, flip, or do we just start factoring? Let's do it. Keep the first fraction, change division to multiplication, and flip the second. So we have our x squared All right, so these are the only 2 that can factor. Go ahead and try to factor those. I'm gonna come around and see what we come up with. Factor the pink and the green. numbers that multiply to 20 and add to 10. And then two numbers that multiply to -6 and add to -1. So our numbers that multiply to 20 but add to 10 would be 2 and 12. Oh, what did I say? Okay, let me say. Numbers that multiply to 20 but add to 12 would be x plus 10 and x plus 2. And our denominator didn't change. Now, it's always a little trickier when one of the numbers is negative. So I'm looking for numbers that are different signs. They multiply to be -6 and add to -1. So that would be a -3 and a +2. And my denominator is already factored. So we're ready to connect it and cancel. Cancel what you can. Has to be up and down to take it away. So, can I cross out an x plus 10? No. What about an x plus 2? So we can cancel out this x plus 2. But there's also another one. So they both, the numerator and denominator, had x plus 2 squared. Is there anything else we can take away? Okay. So that leaves us with our final answer of x plus 10 times x minus 3 all over 4x. All right, two more, and then you'll have the rest of the class period to do the back side of your homework, which you're just looking for GCFs or you're making an X. Do I need to do keep, change, flip for question G? No, let's just factor it out. Is there anything I can do with this x plus 3 and x plus 2? No, it's already done. All right, so now let's go down to this x squared plus 7x plus 10. So we need to find two numbers that multiply to 10 and add to 7. So don't say it out loud. See if you can find the numbers that multiply to 10 but add to 7. Anybody know the numbers? Johan? 5 and 2. So we got positive 5 and positive 2. So we got an x plus 5 and an x plus 2. And the numerator of the second fraction, that's already done for us. They took out the GCF of 8. And in our denominator, we have our special factoring pattern, the difference of squares. Difference of squares. So what multiplies to be x squared is x times x. And what do I multiply to get 9? 3 and 3. One is addition and one is subtraction. So now I'm going to connect it and cancel. Take a moment and cancel out everything that you can. All right, so it's a lot that we can take away. One thing we could take away is an x plus 3 because it's upstairs and downstairs. Then I can also take away an x plus 2 and an x plus 5. So that's only going to leave me with an 8 in the numerator and an x minus 3 in our denominator. All right, what y'all thinking so far? Thumbs up, sideways, down. Just a lot of factoring. That's why I was trying to, all semester, trying to get us ready for this factoring. All right, last one for today is H. Do we need to do a keep, change, flip? We do. Keep, change, flip. So there's three things we can factor. We have our x squared, but then I also have two terms with the GCF. So go ahead and factor down those three. So we're looking for the number that will divide, for the one that's highlighted in blue, what can we divide into 3 and 12? That's what we're looking for. The one in green is pretty easy because it's 2 3s, so we know we can take out a 3. So let's finish it on out. So what are our numbers that multiply to be -4, but add to a +3? What'd you say, Maya? 1 and 4, -1 and 4, good. For our 3x plus 12, we can divide both of those by 3. So the 3 comes out, and I'm left with x plus 4. And for 3x plus 3, if I take out the 3, I'm left with x plus 1. All right, go ahead and cancel out all you can. So Tanya, what's one thing I could cross out? You said -4? I didn't hear you. The 4x plus 4? So let's take away the x plus 4. Bailey, anything else I can cross out? Yep. Yep. And there's something else I could cross out. What else can I take away? The 3's. So that's leaving me with x plus 1 on the top over x minus 3. So go ahead and take out your homework 1 and use this time to work on the back. Now this homework is not due until Tuesday, but if you need help, I am here to answer questions.